So today we're going to do several things. We're going to, first of all, we'll make sure that we recognize a line tangent to a curve. We will recognize the difference quotients and how they express an average rate of change. And we'll know that the instantaneous rate of change of a function at a point can be expressed by the limit as h approaches 0 of f of a plus h minus f of a over h, or the limit as x approaches a of f of x minus f of a over x minus a. Okay? Alright, so what we have here, this is a tangent line. It's tangent to the curve at point P. So it touches it, and it has the same slope as the curve does at point P. Okay, so the slope of the line equals the slope of the curve. Now these lines, where we have these over here, we have from P to this first Q over here, these are all secant. This is a secant, this is a secant, this is a secant, and then of course this is the tangent. You can see as the point Q gets closer on the curve to point P, those secant lines become closer and closer to being that tangent line. And that's the idea we use here to find the slope of a tangent line, is we imagine that the point is getting closer and closer to the point we're interested in, so it's so close you can hardly tell the difference between the 2 points, and we're taking the slope. And that's why we're using limits. We're basically taking the limit as point Q approaches point P. Okay? So the slope of the secant would be, the y from Q minus the y from P over the x from Q, okay, minus the x from P. And the slope of the tangent would essentially be the limit as Q approaches P of this. Okay. Now, so we're talking about the slope of a line tangent to a curve at a point. Okay. We're going to use that idea that we just talked about with the secant lines and finding the slope of the secant lines, and the slope of the tangent is the limit of the slope. So we know that we can also take the slope of a secant as f of a minus f of b over a minus b. Okay? And the way it's written up above here, f of x minus f of a over x minus a. Okay, that's the slope formula. That's y2 minus y1 over x2 minus x1. Okay? And the third way of writing it is f of a plus h minus f of a all over h. And h is just the difference between a and the point that it's getting closer and closer to there. Right. So the slope of a tangent line, it would be one of these things, the limit as x approaches a of f of x minus f of a over x minus a. Or, one we're going to find more useful is the limit as h approaches 0 of f of a plus h minus f of a all over h. And both of these are useful, and you should recognize them both, certainly, and they will test you on your knowledge of these. But yeah, we one of the tests will be, do you recognize this format, like this format or this format, as the definition of a derivative, as we're going to see it in the next few days here. Alright, so it says find the equation of the line tangent to the curve y equals x cubed at the point 1, 1. Okay, well, so let's use, we want to use one of these. We're going to use this first one here. we're going to take the limit to find the slope. We have to find if we're going to find the equation of a line, we need the slope and we need a point, which we have a point. We have the point 1, 1. And then we'll write our equation in point slope form. Okay. So the limit as x approaches 1 of f of x minus f of 1 over x minus 1. Well, we know that f of x is x cubed. So it would be the limit as x approaches 1 of x cubed minus 1 over x minus 1. Now, of course, our first thing to do is to try plugging in the 1 and see if we get an answer, as we always do with limits. But if we plug 1 into here, 1 cubed minus 1 is 0, and 1 minus 1 is 0, we get 0 over 0, so that doesn't help us. So we then try factoring or some other algebra to try to simplify. Well, this is the difference of 2 cubes. We know we can factor that. So it'd be x minus 1, and then x squared plus 1x plus 1 over x minus 1. Okay. Now we see we have an x minus 1 here and here. They cancel. And so we take, and now we can plug into what we have left. We can now plug in 1, which would be, okay, 1 squared is 1 plus 1 plus 1 is 3. So that's the slope. And now we just plug it into here and get our equation. Y equals, it's the 0.11, so 1 plus 3 times x minus 1. There is the equation to that tangent line. Okay. All right. Now, okay, so that other useful form is that limit as h approaches 0 of f of a plus h minus f of a over h. And we're going to use that one to do our next problem. Okay. Find the equation of the line tangent to the hyperbola y equals 3 over x at the point 3, 1. So we're going to plug this in, and of course this is our f of x. So it'll be the limit as h approaches 0 of, we put a plus h in for x, so 3 over a plus h. That would be our f of a plus h. Minus f of a, which is just 3 over a, all over h. Now we know that this is a and this is f of a. So we're going to plug 1 in for, or plug 3 in for a. So that would go to the limit as h approaches 0 of 3 over 3 plus h minus 3 over 3 all over h. Which then that of course is just 1. 3 divided by 3 is just 1. So that'd be 3 over 3 plus h minus 1 over h. And now we have to convert this into, we have a fraction within a fraction here, and so we want to do a little bit with that. So we're going to make this here, this 1 is going to be 3 plus h over 3 plus h, because then we can give them the same denominator and we can combine those. And what we have then is the limit as h approaches 0 of 3 minus 3 plus h. That's right here, 3 minus 3 plus h over 3 plus h, because they have the same denominator, all over h. Which leads to our next thing. We have this fraction within a fraction. When we have two denominators that we can essentially, we combine the two denominators together. So we end up with this, 3 minus 3 plus h over 3 plus h times h. We just move this up here and make the two denominators into one by multiplying them together. Okay, a little bit of simplifying here. 3 minus 3, that's going to cancel out. So what's left on top there is, when this cancels, is just negative h over 3 plus h times h. Of course, those h's now cancel, and so I'm left with the limit as h approaches 0 of negative 1 over 3 plus h. And now I can plug in 0 for h. So it's negative 1/3. That is my slope. Now I just write the equation of my line. Y equals 1 plus negative 1/3 times x minus 3 is the equation of the line tangent to that hyperbola at the point 3, 1. All right. Velocity. Okay. Velocity. There are two types of velocity. There's average velocity. And if I use 600 miles in 12 hours, 600 miles in 12 hours, our average velocity would be 600 divided by 12, which is 50 miles per hour. See, 50 miles per hour. That's average velocity. You have a distance you traveled divided by how long it took you to get there. There's an instantaneous velocity. Which an instantaneous velocity is, that's what you see on your speedometer when you're driving your car. That is your instantaneous velocity. What you see, and this would be the limit of average velocity. So we could use the limit as h approaches 0 of f of a plus h minus f of a over h. So we think about, just like this, these are like the secants, the average velocity, they're like the secants, and this is like the tangent. And the slope of the tangent equals the slope of the curve. The same thing, the instantaneous velocity is that's how fast we are traveling at that instant. Okay, where average velocity is over a period of time. Alright, so suppose a ball is dropped from the second observation deck of the Empire State Building 1,250 feet above the ground. This is, what is the velocity of the ball after 12 seconds? How fast is the ball traveling when it hits the ground? Okay, so we need a little bit more information here to determine that. And that has to do with the a formula for the position of the ball, and it would be this. And we'll use F, but sometimes we use S for a position function, which is what this is. Okay. And so since we're dealing with feet, it's going to be 16t squared. That would be how far the ball has traveled in t seconds. Okay. So if we want to take and find the velocity, we have to take the limit as h approaches 0 of that f of a plus h, this formula here. So we put a plus h, so it'd be 16 a plus h squared minus 16 a squared all over h. Now I know that a is 3 seconds, so I need to plug in a. So I plug in for a. 3 plus h squared minus 16 times 3 squared all over h. FOIL out this and multiply this out. This would be 16 times 3 squared plus 6h plus h squared minus that's 9. 3 squared is 9 times 6 is 144 all over h. And now I distribute. Okay. I have to distribute this into here, and I would get 16 times 9, again 144, plus 16 times 6, which is 96, plus 16h squared minus 144 all over h. So this is 96h. I'm sorry about that, 96h. So the 144 and this 144 cancel, and then I have 96h plus 16h squared over h. That h cancels, one of those h cancels, and I'm left with 96 plus 16h. Now I can plug in 0. We can take the limit as h approaches 0, and that's going to drop out, so it's just 96. So it's 96 feet per second after 3 seconds. Okay. 96 feet per second after 3 seconds. That would be the velocity. That's A. B. How fast is the ball traveling when it hits the ground? Well, I'll let you finish the process, but the first thing we have to do is do 16t squared, okay, equals 1250. And the first thing we have to do is solve for that. And then repeat what we did in A. And we're obviously, this time, A would equal whatever number we get when we solve this equation. And I'll let you do that for yourself. Okay. All right, a ball is thrown upward with a velocity of 60 feet per second. Its height after t seconds is given by y equals 60t minus 16t squared. Find the velocity when t equals 1. Okay, so we have our function. So we are going to do to find the velocity, the limit as h approaches 0 of 60 times 1 plus h, because we're going to plug in the 1, minus 16 times 1 plus h squared, minus 60 times 1 minus 16 times 1 squared all over h. We simplify that. So 60, we distribute here, 60 plus 60h, minus, we FOIL this out, 16 times 1 plus 2h plus h squared, minus, I'm going to put parentheses around that. This is 60 and this is 16, so minus, what is 44 all over h. Use an arrow instead of an equal sign there. Distribute this and combine like terms. So we'd have this. So minus 16, minus 32h, because we have to distribute that negative with the 16, minus 16h squared, and minus 44. All over h. Okay, now every time we do this, everything that doesn't have an h in it should cancel out. And you'll see the 60 and the minus 16 and the minus 44 are the only things without an h in them. Well, 60 minus 16 is 44, and 44 minus 44, of course, is 0. So those three things cancel out. And then I'm left with 60h, use an arrow instead of a, minus 32h, minus 16h squared all over h. And since all of them have an h, I can cancel this h out with this one, and one of these. So I have 60 minus 32, which is 28, minus 16h. And now I can take the limit as h approaches 0, which would just drop that minus 16h, and that would be 28. So that is 28 feet per second, okay, at t equals 1.